Hi, I'm Chris, and in this calc video we're going to take a look at a ratio test, which is something that if you're studying for your AP Calc BC exam, you're probably seeing a lot of right now. So we're going to take a look at it for this sample problem, but before we get into solving this actual problem, I want to make sure we understand what the point of a ratio test is. So a ratio test is to determine if a series is going to be convergent or divergent, which means is the series, when you sum everything together, is it going to approach a single value or is it going to continue off towards infinity? And the way that we can tell that is by looking at a ratio of a sub n plus 1 to a sub n, which basically means that you're looking at the ratio of one of the terms over the term that comes before it in the series. So let me give you just a very quick example of something like that. If you had a geometric series that went 1, 2, 4, 8, and so forth, if everything was being doubled, then if you picked any given term anywhere in this series, let's say we take a look at 4, and then we take a look at the term before it, we take a look at 2, 4 over 2, the absolute value of that would give us 2, which basically means that since this is a value greater than 1, that this is going to diverge, or another way of saying that is that the sum of this series, if you were to continue adding this up all the way to infinity, you would get an infinitely large value. So that's the purpose of a ratio test. You're really just taking the ratio of one term to the term that comes before it. And when we solve for L, which the reason we call it L is because we're going to use limits to approach this, then that will allow us to determine whether it converges or diverges. So let's try this out in this example. So first, let's show why this is a good example of where we would want to use ratio test. Because that's the number one question I get from students is, well, how do I know which test to use? So let's just take a quick look so that we understand why ratio test is a good one to use here. If we were to take a look at this and actually plug in the values of n to see what the first few terms are, you'll notice when we write out these terms that it would be very difficult for us in this particular series to predict what the convergence or divergence would be based on the first few values. And let me show you why that's the case. If we plug in a 1, we get 1/2. If we plug in a 2, we get 2 squared, which is 4, over 2 squared, which is 4. So this will simplify to 1, and I'll write that in later on. If we plug in a 3, we get 9 over 2 to the third, which is 8. If we plug in a 4, we get 16 over 2 to the fourth, which is 16. If we plug in a 5, we get 25 over 2 to the fifth, which is 32. And if we plug in a 6, we get 36 over 2 to the sixth, which is 64. So if you look at these terms, and I'm going to simplify the ones that can be reduced to 1, just so we can see what's happening here. Oops, let me reduce that one. 36 over 64 reduces to 9 over 16. Okay, so let's take a look at these first few terms and talk about them briefly. So from 1/2 to 1, if we look at what we're multiplying these by, we're multiplying by some factor in order for this to be a 1. That means we're multiplying by 2, and it's going to be a factor that's greater than 1. If we go from 1 to 9 over 8, we're multiplying times 9 over 8, which again, that ratio would be greater than 1. But now we're multiplying by 8/9 to get here, and we're multiplying by 25/32 to get here, and so forth. So what we notice from that is we're multiplying by something different each time. So it's a little bit more difficult for us than on that first example with the 1, 2, 4, 8, etc. that we looked at to see what that ratio is from term to term if we were to just look at it numerically. And that's where ratio test comes in. It gives us a way of calculating the answer to something like this when it's very difficult to glance at a particular series and figure out a numerical relationship between the terms. So let's take a look at how we can actually apply this test. If we use this general formula that we see up here, the limit as n approaches infinity of a sub n plus 1 is going to basically mean you're plugging in an n plus 1 in place of each n that you have here. So that would be n plus 1 squared over 2 to the n plus 1. And then divided by, since our term that we're looking at here is written as a fraction, when you divide by a fraction, it's the same as multiplying by the reciprocal. So our original term n, we're going to just keep as n, but remember it's going to be the reciprocal because you're dividing by a fraction, so it would be the same as if you multiplied by this reciprocal. N plus 1 squared. Down here, whoops, not n plus 1 squared. Just kidding, n squared down here. And that's what we're going to solve for. That's what we're going to try to simplify for this problem. Now, it's really important when applying ratio tests that we know our exponent rules very well. So in this case, if you have n plus 1, you can split that up. And I'm going to write out the steps for that here. But this will basically, when we FOIL that, you'll get n squared plus 2n plus 1 over, and this is going to be 2 to the n times 2 to the first, which is just times 2. And then times, over here, we're going to have 2 to the n over n squared. Now, when we go to simplify this, 2 to the n will cancel out. And so what we're left with is just going to be n squared plus 2n plus 1 all over 2n squared. And when we take the limit of this as n approaches infinity, what's really important to appreciate here is that now, since you have the same degree, then your limit as n approaches infinity will be the ratio of the coefficients on that term with the highest degree, which here means a ratio of these two. So it would be 1 over 2 as your value. And if we look at what that means in terms of convergent or divergent, or inconclusive if it comes out equal to 1, in this case, 1/2 is less than 1, which means that this particular series that we're looking at will be convergent. So I'm going to step aside and let you take another moment to look through the work that we did here. And please feel free to make any notes that you want on a problem like this, but the most important thing to take away is ratio test shows you how you can take this general formula and apply it to a specific problem when it's too difficult to figure out convergence or divergence by strictly looking at the numbers that would show up in the series. For more, please feel free to check out our other videos, and thanks for watching.